Welcome. In this video, we're going to talk about defect management. It's an important aspect of quality assurance. In all software projects, it's typical to find a lot of bugs during the various testing phases and while executing test cases. And in this video, we're going to talk about how to log defects or bugs. I'm going to use these terms interchangeably. Defects are bugs and bugs are defects. So we're going to talk about how to log bugs in a standard format, the bug life cycle, and how to, who logs bugs and how to triage them, how to get them fixed, how to get them closed out, and what are the guidelines for testing. So if you have not already watched my video about standard QA testing best practices, please watch that video before you watch the video on defect management, because you might understand this video better if you know the standard test case practices. So let's take a look at quality assurance, specifically defect management. So the agenda of this video will be how to log bugs and defects in a standard format, defect management and resolution, defect life cycle, bug triages. So what is a bug or a defect? So when a customer or a product owner has given you some specifications telling you they want the software or a product, in any situation they have a certain expectation. They expect the system to behave in a certain way, and if the system behaves in any way other than specification, then it's a defect. Then we have to do the needful. We have to fix the defect to make it behave the way it was supposed to behave. So in any organization, quality assurance assumes at least 33% of the time taken in the entire project life cycle. It could be anywhere from 30 to 50%. I've seen projects where 50% of the work was all about testing and defect management. It's really a very critical and important aspect of any project life cycle. So bugs may be found at any stage. So once we gather the user requirements and translate them into system level specifications, the developers start developing or coding a software project. And during development, the developer might himself find a lot of bugs and fix them. Those are called unit tests. And sometimes after development, they migrate the code into the QA environment, and the testers might find defects in the QA environment. There are people who are dedicated resources for testing. So they might find a variety of bugs, including UI bugs or user interface bugs. These are related to the look and feel of the website and the pages. And during positive testing, so you give a positive input and the system is supposed to give you a positive output. So if that doesn't happen, then it's called a defect that's found in positive testing. Or you might find defects in negative testing. So negative testing means you try to crash the system in every possible way. You give a negative input to the system and make sure the system doesn't crash. The system must be able to gracefully exit by giving you the appropriate error message. That is negative testing. What is regression testing? So if you have developed a particular functionality and everything is working fine, and then you develop another functionality which adds on to this functionality, and in the process of developing new functionality, you might have broken something that was previously working. So that regression testing is a process by which you ensure that you haven't broken anything that was previously working fine. So performance testing. This includes load and stress testing, especially when it comes to websites and web-based testing, or even any enterprise application testing. If there's going to be like thousands or even sometimes millions of users hitting the website in a very short span of time, the web servers may not be able to withstand the load and they may just crash. If you're from India, I mean in the engineering colleges a few years ago, that's the way it used to be. On the day of the results, all the students would log in to the university website, and very often it would crash, it would be very slow, things like that. So they have to use a lot of distributed servers, and make sure the server can withstand the load or the stress. So there are tools which simulate the performance of a website when it's likely to be hit by millions of users, and there are simulation tools like Load Runner, that's an automated test tool, and they try to make sure the website can withstand the number of hits that it is likely to receive. So we're going to talk about some definitions of the different types of testing. User interface test cases, UI test cases, are used to test and make sure that all the UI elements on a page, that is the buttons, text, font, labels, checkboxes, borders, display, colors, scroll bars, all these are correctly displayed and aligned in various browsers, operating systems, and other parameters. So if you're developing a website, everything might be working fine in Chrome browser, but if you're using Firefox or Internet Explorer, it may not work properly. Or if you try and use it on a mobile device, it may not be working fine. So you have to make sure it works on all browsers that it is supposed to be working on. And you have to make sure the font is displayed correctly, the labels are correct, they're of the right color, right size, and aligned correctly. So user interface testing is all about the look and feel of the page. Positive testing. So positive testing is when you provide the right input to the system and make sure you get the right output. It's like happy path testing. It's a happy path scenario. For example, if you're testing the login module of a website, you give the correct username and the correct password, and the expected output should be that the system logs you in successfully. That's an example of a positive test case. Negative testing. This is where you provide various types of incorrect data, boundary conditions, special characters, etc., and try every way to try and crash the system and make sure the system always exits gracefully. That's negative testing. For example, if you're testing a login module, you can give an incorrect username and incorrect password, and the system should give you the appropriate error message. It shouldn't crash. Or you can give the correct username and an incorrect password and try to log in. It still should give you the appropriate error message. Or you give the incorrect username and the right password. There are different ways in which you can try and crash the system, or you might give a very long username or something like that. And in every way you have to make sure that the system exits gracefully, and that is negative testing. Regression testing. Now let's take an example of the login module for a website, for example like Facebook.com or Amazon.com. Suppose you developed the login module and it's working fine, and it's been working fine for 3 months, and then people work on the reset password or forgot password module. So they develop this new functionality wherein if the user has forgotten his password, he can reset the password by clicking on the forgot password option. And they develop this new functionality, and in this process they might break the functionality that was previously working fine. So the login functionality might now not be working fine because of this new functionality that somehow messed up the previous code. So during regression testing, we re-execute all the test cases that were working fine. We identify all those aspects of a system which might be impacted by new functionality. So in the process of developing the reset password functionality, what are all the modules that might have been affected? We make a list of all those modules and re-execute all those test cases as part of regression testing to make sure that the system is working fine. So bugs in manual and automated tests. So manual testing is when a human being, a tester, is sitting and executing test cases step by step, or going through the application step by step and trying to see if something is not working fine. And then they log defects and get them fixed. That's manual testing. Automated testing is when we use software like QTP, that's Quick Test Pro, Load Runner, or Selenium. These are a lot of automated testing tools which can be trained. So you can train QTP by recording a whole testing scenario. You execute a whole lot of steps in the train mode, and the software QTP records this test step by step, and then it can re-execute the same test multiple times, so you don't have to do it each time. Let's think of a website like Expedia.com or Yatra.com. These are websites where people can book air tickets, hotels, rental cars online. Just think about booking a flight ticket all over the world from any destination to any other destination. That's such a complex process, and it has to be done in real time. You can't imagine manual testers sitting there every day and making sure that every source and destination is working fine when people are trying to book tickets. So they run this pre-recorded train, test sets, test cases again and again every day to make sure everything's working fine. Like for example, within North America, there may be hundreds of airports. So for example, if you're flying from San Jose to various other destinations, you want to test and make sure all the other destinations are working fine. So there's New York, there's Los Angeles, there's Cincinnati, there's Miami, there's all these other destinations. How can you probably test each one of them to make sure it's working fine? So these automated software, they use something called parameterization. So you put all these sources and destinations in like an Excel file in two separate lists, two columns, and it automatically matches each item in each list to every other item in the other column. So it makes sure like every source and destination is working fine. So these are some of the simple advantages of using automated software. It reduces human effort, and it's used for very complex operations, and it can do a lot of time-consuming operations in a very short span of time, and it's sometimes more reliable than using manual effort. LoadRunner is an automated software tool that is used for performance testing. It's used especially for stress or load testing. Selenium is another automated software tool. So in manual testing, who logs the bugs? The quality assurance resources, the testers, they log the bugs manually and triage them and get them fixed and closed out. But in automated testing, usually the test tools automatically create bugs. And sometimes they have to be manually triaged and fixed and closed. Typical types of bugs. So you might find user interface related bugs, functional bugs, integration related bugs. So what is an integration bug? For example, if a company is implementing a complex ERP project, like ERP is enterprise resource planning, that is, managing all the operations of a company. For example, for CRM, that's customer relationship management, they may be using a software like Salesforce. But for their financial systems, they might be using SAP financial systems. And for their payroll, they may be using SAP again, that's a different module. And for their time cards, that's a whole different module. They might be using something like Lotus Notes. And for something else like clinical software or something, they may be using a software like Aptus. There are so many different software systems that could be used in a company. And we have to build pipes or interfaces between all these different systems. For example, if a company is using Salesforce CRM for their CRM operations, and from the CRM they have to feed in all the number of hours that employees worked to Lotus Notes for the time cards. And based on that, based on their salary or the hourly rate, they have to feed all that information, financial information, to the payroll system or SAP financial system. So we have to build an interface to transfer data between Salesforce to SAP and back from SAP to Salesforce. So these interfaces are built using standard software, and we have to test and make sure the interfaces are working fine, and there may be a lot of bugs found in integration or interface testing. Regression testing. So a bug might be purely a regression bug, meaning it was working fine, but in the process of developing the new code, they broke the previously existing code. So that could be a regression bug. Or a bug could be database related. So somebody might have messed up the database. They might have performed an incorrect operation in the database, or breached the security in the database, or maybe the SQL queries were not written correctly. There might be some exception somewhere. Or it might be an architectural bug, meaning maybe the architect solutioned the system in such a way that it was working for a particular level of complexity, but it wasn't scalable. Or maybe they didn't think about how a particular module would impact another module. probably they didn't map the dependencies of the functionality, right? So there could be various different ways. These are just some of the types of bugs that could be found in the system. So bugs may be logged against test cases, user stories, or epic stories. Let's take a look at some of the artifacts in a software project. So the artifacts are usually stored in a hierarchical structure. So there are a lot of tools like Rally, Jira, TFS, Team Foundation Server, or so many other tools wherein people can write user stories, they can write test cases, they can log their defects and maintain it, and also let them run through their life cycle. So, and for example, the hierarchical structure in a typical project would be initiatives. Under that we have multiple features. Under that we have multiple epic stories. Under that we have individual user stories. And each user story can have multiple test cases and defects and tasks. So an initiative is like a very high level component of a project. For example, if it's a Salesforce project, there's something called the Sales Cloud and the Service Cloud. Sales might be an initiative, and marketing might be an initiative, and services might be a whole initiative by itself. And under each of these, we can have multiple features. For example, if there is a help desk module that needs to be developed in the project, like if your laptop is not working, you call up Dell help desk, right, for technical support. Most of these organizations offer technical support in the form of help desk module. So that whole module can be a feature. Sometimes if they are selling solutions that need servicing, they might need to send technicians on site, and they have to give work orders to the technician to go resolve the problems and come back and capture their hours and all this stuff. So that is a feature by itself called field service. For example, if a company is into providing training and consulting services, so they have to go to the client side and train them on how to use different products and offer consulting services, that whole module on training could be a feature. Sometimes if they're tracking the sales operations, this whole process of getting a purchase order and then signing the contract, and this whole sales operation, that could be a feature. And sometimes this whole process of contracts and entitlements and warranties, how a contract is signed and how the warranties are signed, that could be a feature, for example. And a feature is a high-level artifact. So one feature can have multiple epic stories under it. So these product owners from the business team, they write a lot of user stories. So they write various epic stories, they create various epic stories, which each epic story is supposed to do a whole big lump of functionality. For example, in the help desk module, let's take that, that's an easy thing. So for example, a customer can call by phone and log a case, or he can send an email and create a case, or he could, probably log a case in some other way on the customer portal or something like that, on the website. So this whole thing is about case initiation, how the case is initiated, and that could be a user story, an epic story, sorry. So the individual user stories, you might have like 3 different stories for 3 different scenarios. Like the customer calls by phone and tries to create a case, and if the case already exists, the system must update the case, else it must create the case and give him a number, case ID. So this whole thing about initiating a case by phone is one user story. Initiating a case by email is another story. And initiating a case on the customer portal is another story. So these could be 3 different user stories. Test cases. So each user story can have multiple test cases under it. There's UI test cases, positive test cases, negative test cases, and regression test cases, and all these test cases for each user story. And so that was about the hierarchical structure of storing artifacts in a software project. And let's talk about the various testing phases. So there's something called end-to-end system testing or functional testing. So end-to-end system testing means it's about testing all the functionality within the confines of a particular system. So if you're testing something within Salesforce, you don't really test the interfaces that go out of Salesforce. If you're testing something in SAP Sales and Distribution module, you test only that particular module. You don't test the interface that goes to other systems. So within the system, you try and make sure you do the positive, negative, regression, UI testing, and make sure that everything's working within that particular system. It's like within this box, everything's working fine. And next step is we talk about system integration testing. So we test all these interfaces that go from one system to another. So we actually send data across the interface to other systems and make sure it's processing them right and the data comes back processed correctly. So this is about system integration testing. So user acceptance test. Suppose the customer has outsourced a project to a particular company to implement, or a team to implement. And after implementing the project, the team will actually give it back to the product owners or to the customer to test the projects, to test and make sure the software is working fine. This is called UAT. And the user acceptance test means the product owners and customer will test the product and see if they can find any bugs. So usually the end-to-end system testing and system integration testing would have already happened before we go to the UAT phase. So the implementation partner or the project team that's implementing would already have found a lot of bugs and fixed all of them, and when they think the system is stable, they give it to the customer or the business owners to test and see if they can find any bugs. Validation testing. The validation team will re-execute a select subset of the UAT test cases and record details of execution in the system for compliance, such as FDA audits, ISO 9000 compliance, and things like that. So a lot of these companies have to show the auditors that a particular important subset of test cases have been executed. And this is called validation testing. It's particularly important for compliance reasons. And we don't have to show them that we executed all these test cases. We just have to show them that the important test cases were executed. So let's talk about the actual format in which we log bugs. So any bug in any software project, any company, is logged in a standard format in the world. So if you're a tester anywhere in the world, and if you're asked to log a defect, this is how you would do it. You record the actual result. What do you see while testing? When you're executing the test cases, what do you actually see? So that's what you write here, the actual result. Expected result. What you expected to see. How was the system supposed to behave? That's expected result. And steps to reproduce. How to reproduce this bug. So what exactly did you do? What login credentials did you use? Which browser did you use? Which operating system did you use? And what did you do step by step? How did you reproduce? How did you get this bug? You have to let them know so that they can reproduce it. And then in the attachments, we attach like screenshots usually, because a picture speaks 1,000 words. So sometimes without a screenshot, the developers might never understand what this bug is all about, no matter how you describe it, how articulately you describe it in words. So you include a screenshot and you say, look, this is what I found. This UI element is not of the right color, or this is misaligned, or I gave a positive input and a positive like username, positive password, and I tried to log in, and instead of taking me to the My Profile page, it took me to the Purchase Now page. So that's a bug. So, and sometimes it gives you a server error. You have to take a screenshot, and so they know exactly what the error is. And sometimes you can have other data used in Excel sheets and things like that to say what this bug is all about. For example, this is a sample bug. Actual result. When I log in on the home page using an incorrect username and correct password, system displays an incorrect error message saying password is incorrect. So we used the correct password and we used a wrong username. So the error message was supposed to say, what was the error message supposed to say? Well, I think the correct error message would be that the username was incorrect. But the error message displayed would be that the password is incorrect. And that's wrong. Because we used the right password, but we used the wrong username. So it has to display the appropriate error message. Steps to reproduce. For example, if you're on test.facebook.com, suppose that's the website you're testing. So how did you reproduce this bug? Log in on the home page using a correct username. Say john@gmail.com. This was the username I used. And suppose you use an incorrect password like abcd12 and hit the submit button. Observe that the incorrect error message, incorrect password, is displayed. So there could be various ways in which we might have goofed up. So we might be using an incorrect username and a correct password, or a correct username and an incorrect password. There could be many scenarios in which we can get bugs. So what is it that you saw? What was it you're supposed to see? And how did you get to this page? Attach screenshots. That's what the format of a bug is all about. So if the error message was supposed to say password incorrect and instead it says username incorrect, that's a bug. Suppose the error message was supposed to say username incorrect and instead it says password incorrect, that's also a bug. So what is it you saw? What was it you were expecting to see? And how did you reproduce it? That's exactly the format of a bug. So in a bug, if you're using a software like Rally, or you can actually go to like Rally, look for Rally online. Rally is a software you can get a free trial license and play around in the sandbox for a few weeks. Try and log bugs and play around in the system. How to fill all the fields in the bug? So the environment. So whoever is logging bugs must say in which environment they found a bug. Did you find it in the development environment, or the test environment, or the UAT, staging, or on production? So they have to, in the drop down, they have to pick in which environment they found the bug. Usually the QA or testing resources are supposed to find bugs only in the QA environment or above, meaning in the UAT or staging or production. Usually nobody but the developers must play around in the development environment. So we talk about found in. We talk about which environment which build, the codes have something called builds. That is, every now and then they deploy to the server. That's called a build. In which particular build there was the defect found? For example, SFPC4, that might be the name of the environment in the build in which they found this, and sprint 7. A sprint is usually a 2 or 3 week cycle, and during this sprint on this environment they found this bug. That's what they're trying to say in this particular build. Or the build might have a particular name, so they might say in this particular build I found this bug in this environment. So in the QA environment, in this particular build I found the bug. And then the target build, the environment in which the defect is targeted to be fixed by the development team. So they found this bug, they've identified it, and they realized how to fix it, and then they give it to the developer saying, okay, by the time we do this build, 3 days later, we must have this fixed. And the target build is going to be, SFPC2, it's still going to be sprint 7 probably. So in the same sprint, within the next 3 days or 5 days, this particular build, you're supposed to have this bug fixed. That's like an estimated target build, during which time we hope the bug will be fixed and deployed. Fixed in. So once we identify the bug and the root cause and give it to the developers to be fixed, once the developer fixes it, he says in which environment he fixed it, and that he logs in, say SFPC2 sprint 8. So he actually took 2 or 3 weeks to fix this bug, and in sprint 8, in which particular build he fixed this. So the developer records that. Deployed to. After the defect is fixed, the release engineer must deploy it to the test environment. So once the developer fixes it in the development environment, he has to inform the release engineer to migrate it to the particular environment in which the bug was originally found. So if the bug was found in the UAT environment, they must move it all the way to fix it in the development environment, move it to QA, move it to UAT, and then in the particular environment in which it was originally found, they give it to the tester to retest and close. So if they found it in production, They have to again fix it in the development environment, move it to like QA, UAT, staging, and then production. There might be sometimes a shortcut in case of hot fixes, and then in whichever environment the bug was found, it has to be retested in the same environment before it can be closed out. So verified in. So the release engineer has to migrate it to the same environment in which it was originally found. So like in the previous slide, we talked about found in, right? The environment in which it was found. So the release engineer, he moves it, migrates the bug, and when deployed to is the same as found in, then he gives it back to the person who logged the bug to retest it and close. Remember, every bug has to be retested in the same environment in which it was originally found before it can be closed. Verified in. So when the person is retesting it, and this time he says, hey, this is working fine. So he says in which environment, which particular build he retested it. Or the person may say in which particular build he retested it and the bug was not fixed. So this is a record of in which build they tried to retest the bug. States of a defect. Submitted. Default state of a defect when someone logs it is submitted. So if I'm logging a bug, by default it's in submitted state. In progress. When a dev is assigned to fix a defect, so we give it to a particular developer to fix this defect, he changes the state of the defect to in progress while he is working to fix it. So the developer is trying to fix this bug, working really hard, and he picks the status in progress from the drop down. Fixed. So the developer has finished fixing the bug. He changes the state to fixed. Closed. So after he has fixed it, we migrate it to the particular environment in which it was originally found, and the person who submitted the bug, or one of his team members, will retest it, and they say, hey, this problem is, it's no longer exists, so they can close out the bug. Or sometimes, when a bug is logged, we mark the status to deferred, meaning the defect cannot be fixed immediately for a variety of reasons. So maybe it involves a huge architectural change that's going to take 2 months to happen, and only then the bug can be fixed. Or maybe the release engineer is gone on vacation, and till he returns after a week, the code is not going to be, the code cannot be migrated to the UAT environment in which it was originally found. So that might be the reason. So it's in a deferred state for a week. For a variety of reasons, a bug might be deferred. They decide that it's not going to be fixed right anytime soon. Reopened. So when a person retests a defect that was fixed, and he says, hey, the problem still exists, you didn't fix it right. So then he marks the status to reopened and gives it, then they go through the bug triage again, and they give it back to the developer or some other developer to again fix it. So defect life cycle. So there's usually 6 states. So submitted, and then it goes through a bug triage. That's a meeting where people decide the root cause of the bug. And then they identify a particular developer who will fix the bug. And the developer, it's assigned to the particular developer who's the best person to fix this. And then there's usually something called like in progress. So when the developer is working on a bug, he marks it in progress. That's optional, you can have that status. And then fixed. Once the developer has fixed the bug, he marks it as fixed. Closed. The person who submits the defect, retests the defect, and it no longer exists, he closes it. Deferred is when we're not working on it right now. Reopened. And so the defect was not really fixed, so it still exists. That's reopened. Resolution categories for defects. So a bug might be resolved in a variety of ways, and it's usually good to have a drop-down in your software system. You can custom add a drop-down. So the developer who fixes the bug records how he fixed the bug. So maybe it was an architectural change. So by changing a whole underlying architecture, that's how they fixed the bug. Or maybe it was a simple code change. By changing something in the code, they fixed it. Or maybe it was a configuration change. Maybe by changing something in the page layout, they fixed the bug. Database change. Maybe by altering a SQL query or settings of the database, they could fix it. maybe it was a duplicate. Sometimes you log a bug and then during the triage or you give it a developer, at some point they realize, hey, this bug is a duplicate. We already have someone else who's logged the same bug. So this bug that has been logged doesn't need to be fixed because it's a duplicate of this bug. So they usually log the number of the other bug and tie to that if possible, and they just close out this bug. So it was fixed and closed out because it was a duplicate. I mean, we don't even mark it fixed. Sometimes we just directly close it out. Mark the reason as duplicate and just close it out directly. So, need more information. Sometimes you give to a developer to fix and he says, I can't work on this. So he says that this bug is still in progress, but then he marks it like fixed and says, need more information. So it goes back to the bug triage where they discuss, what to do, and then they say it's not really fixed, and then they give him more information and then mark it as reopened. So that's usually what happens. So not a defect. So sometimes a tester might log a defect thinking it's a defect, and then during the bug triage, the product owners and business analysts and the technical architect, they all review the bug and they say, hey, this is not even a defect. This is working the way it's supposed to work. This happens sometimes. So the bug is closed out directly, and the reason is it was not even a defect in the first place. Defect resolution, meaning, so there was a defect that was logged, and in some miscellaneous random way they resolved it. They discussed it, they tried to tweak something around, and then if it doesn't fit in any of the other categories, we say it was resolved in some generic way. A software limitation. So sometimes a software may not perform a certain functionality of a function that a person expects. So sometimes let's say it's supposed to automatically notify a help desk agent by sending an email, but the particular software package that we're using may not send automatic notifications. So it might be a software limitation. So there is no way you can make the system do it. The product owners, the business team, they want automatic notifications. They've specified, they requested it, and it's not happening. So the tester logs a defect, but the developer says, or the architect says, hey, we can't make the system do this. It's a limitation of the system. So that defect might be closed out saying, we can't implement this. It's a software limitation. Or sometimes if there's a way to overcome this limitation by using a third-party plugin or some other software, they might use it to fix the defect. UI. So if the defect was a UI cosmetic defect and they fixed it by making UI changes, they mark it as a user interface bug. How did they resolve it? By making UI changes. Requirement gap. So sometimes the customer gives you a whole set of requirements and specifications, and he forgot to give you some details, and the developer might have made his own assumptions, or it was not doing something simply because the customer didn't specify exactly how to do it. There was not enough requirements in the first place. So they identified the requirement gap and got the details from the customer, and then they fixed the functionality. They resolved it by closing this requirement gap. Data analysis. Sometimes a bug is caused due to wrong data. Like instead of giving a particular kind of data, they might be feeding in the wrong data. So once they fix the type of data that's going into the system, it might resolve the bug. Roles and profiles. Sometimes a bug is caused if a person who is not authorized to do a particular operation tries to do it. For example, if in a particular system, only the manager can approve a leave request, and if the subordinate is trying to approve the leave request and he's not able to do it, the subordinate might log a bug saying, I'm not able to do it. But then that's because he was using the wrong profile. If he had logged in as the manager, only then he would be able to do it. So it's related to how the roles and profiles are configured. That could cause bugs, and you might resolve it by reconfiguring the roles and profiles. A change request. So suppose a customer originally requested a particular type of functionality. Suppose he requested a yellow color box, and then he says, no, actually I want it to be orange color. So that was a change in requirement, clearly. So If he says, you know what, now I want it to be, originally I said I want a yellow color box, but now I want an orange one, that's not really a defect because the system is doing what it was originally supposed to do. So it has to come in the form of a change request, and they have to identify how much time it would take to implement this new change and functionality. And then once the change request is approved, then they change the functionality by logging a defect. That's usually the fastest way. They log a defect and then fix it. So it was changed by, through this change request process. So I have a whole video about change management, so you can watch that and learn all about how change requests and change management works. So we're going to talk about defect priority and severity. So there's 4 levels of priority. We call them P1, P2, P3 and P4. And there's 4 levels of severity: S1, S2, S3 and S4, usually in any software project. So P1 is like a showstopper, P2 is high attention, P3 is medium priority, and P4 is low priority. So severity, S1 is a crash or a data loss, S2 is a major problem, S3 is a minor problem, and S4 is just cosmetic. What is priority? Priority is how urgently a bug needs to be fixed in the project. It's about how time critical it is and how soon it needs to be done. That is priority. It's not necessarily correlated to how serious the issue is. So severity means how severely it's affecting the system. So I'm going to use a lot of examples and talk about priority and severity. So the priority status is set based on the customer's requirements. So the product owners and the QA managers collaborate and decide the priority for each defect during the testing phases. Based on the project priorities, the product fixes are done. So the developers must always fix higher priority bugs before they take on lower priority bugs to fix. So what is severity? So while a tester, when he finds a defect, he can assess how severely it impacts a system. Sometimes it might be so severe that it's not letting you do any happy part testing. It's not letting you do basic stuff. It's crashing the system. So he might assign it a high severity. But it might be happening in some remote part of the system, so the priority might still be low, meaning we don't have to fix it right now. So usually the person who's logging bugs tries to determine the severity by making a best guess. Defect prioritization, P1. Let's take a look at some of the P1 defects. Showstoppers. So P1 defects need to be fixed right now. So the developers usually drop whatever they're doing, they stop developing new code, and they fix P1 defects when they're found. That's usually the way it works. So everything else can wait. It's a showstopper, meaning it's holding up the entire project and it's like the bottleneck, so it needs to be worked on right now. The build cannot be released with this defect. So we cannot migrate the code to the next environment. We cannot release it with this defect in place. It has to be fixed before we migrate code to the next environment. So that's a P1 showstopper defect. When this defect is present, the users cannot execute the critical path of the business processes. So there's usually something called a critical path that needs to be executed to show the product owners that basic functionality is working fine. And it's right on the critical path. So these are P1 defects. So examples of P1 defects are data corruption. So somehow somebody's hacked into your database and all the data is screwed up. That's definitely a P1 defect. And server error. So you try to go to some page, some link, some button somewhere, and it says, HTTP error 404, or server crash, or it displays a server error. That's definitely any crash, like a server error, is always a P1. And then, for example, if you have a help desk case or work order, and you fill out all the mandatory fields and do everything right, and you save it, and it doesn't save, and all your data is lost. It's not doing a basic thing like saving a case or saving a work order successfully. So that's definitely a P1 defect, meaning this is basic functionality that impacts like the rest of the system. So we got to fix this before we fix anything, before we do anything else. So these are some examples of P1 defects. So let's take a look at P2 defects. P2 is high attention or important defects. Does not crash the application but needs urgent attention. Usually must be fixed within 24 hours or as per the SLA, service level agreement. Needs to be fixed before any other medium or low defect should be fixed. So if there's a P1, it definitely gets higher priority than a P2. But P2 must be done before P3 and P4 are done. Examples of P2 defects. Contact person's phone number is stored in his profile, but it's not displayed when the case or the contact person profile is pulled up. So let's say a help desk agent gets a call from the customer, and the customer's phone number, contact person's name and his profile is stored, and he tries to pull up the person's profile and it doesn't come up. This has to be done in real time. So this is an important bug. It needs to be fixed. But it's not like a showstopper. He can still answer phone calls, he can still create a case, he can still go about doing the happy path even if the profile is not shown. So it's not a P1 but a P2. So help desk agent is not allowed to edit the contact person's details in the customer profile. So if there is a customer profile and he's trying to edit his details, so the customer has a new address or a new phone number and the help desk agent is not able to update his profile, so that's a P2. I'm saying he could wait till a couple of days to update his profile. He could make a note on his notepad and do it later, but it's not a showstopper. He can still do a lot of other things in the system, but it's definitely an important bug that needs to be looked into soon. Defect prioritization, P3 or medium priority bugs. So it's not a showstopper or urgent but needs to be fixed soon. So affects the functionality to a minor extent. Should take precedence over low priority defects. Examples of P3 defects. Incorrect error messages being displayed. For example, if the error message is supposed to say, use the correct credentials to log in, and instead it says, your profile is outdated or something. It's displaying the wrong error message. That needs to be fixed. But come on, we can wait for like a couple of days before we can do this, because there's more important things that need to be fixed. There's like, bigger fish to fry. So this is like a small example of a P3 defect. P4 defects are low priority, least priority, and these are usually cosmetic defects. Usually UI related. Does not affect the functionality of the application. And fixing can be deferred until all the other priority defects are fixed. Example of P4 defects. The UI layout is incorrect. So there's some button that's not in the right place, or some checkbox that is misaligned, or some label that's not in the right color. So some font is not correct. It's not affecting the functionality in any way. It's just a cosmetic defect. So this can wait till a lot of other defects are fixed. So that's like usually an example of a P4 defect. And if there's some label misplaced on the remotely accessed page, so we don't have to fix it till everything else is done, but it has to be fixed at some point of time. So this is a P4 defect. Severity of defects. Crash or a data loss. A showstopper crashes the application. So data corruption, server error on any page, inability to save a case, login issues. You have a login, valid username and a valid password and you're not able to log in. Come on, that's definitely a P1. So S2 is a major problem. Affects the functionality to a major extent. So, for example, if there's some field that needs to be edited and you're not able to edit it, that's definitely an S2. S3 is a minor problem. Incorrect error messages, for example. S4 is cosmetic. So it's usually like a spelling mistake or a UI layout error. Now we're going to look at some interesting examples of correlation between priority and severity, and we're going to see sometimes they're not correlated at all, and this is interesting. So priority and severity may not really have a direct correlation all the time. So priority and severity are determined on a case-by-case basis. priority and severity may change over the defect's lifetime. So originally you thought it was an S4, you thought it was a low severity defect, it's not affecting the system. But then you discuss it with your technical architect and he says, oh my god, this is really S2 or S1. You didn't understand it's really impacting the system because it's affecting some of the modules. So you can actually change the severity even before it gets fixed. And it's the same with priority. You thought it's like a really high priority thing that needs to be done like today. But then the business analysts tell you, hey, come on, nobody's going to access that page for the next 2 weeks. So we can wait for like 2 weeks till we fix that bug. So it's actually a low priority, it's not high priority. Or something vice versa. So priority and severity can be changed during the defect life cycle. So let's take an example of a high priority defect with a high severity. Server error on the login page. Oh my god. So any server error anywhere in the application, if you're a tester and you find a server error on any page, you have to mark it as S1. Server error is always like S1, highest severity, because it's crashing a particular page. So you mark it as S1. But if there's like a server error right on the home page or right on the login page, that's like a very prominent page, right? So we got to fix it right now. So that's like P1 and S1. But if you found a server error on some remote page that is not accessed very frequently, that might be P2 or P3. So it really depends. But a server error on a login page is definitely P1 and S1. High priority and high severity. So example of a high priority defect with low severity. So if the company name is misspelled or the wrong logo is displayed in the home page, it's only a cosmetic defect. But the urgency to fix it is immediate. Priority is high, but severity is S4 because it does not affect the functionality. So imagine a company like Apple.com or like Facebook.com. Suppose there's like a spelling mistake on the homepage, or they put like the wrong logo. So they were making multiple versions of the logo and they used a wrong version. They didn't put the right logo. So the whole world is going to be noticing it, even if it's up there only for 5 minutes, right? Oh my god, we can't let that happen. So if there's a spelling mistake or a UI defect on a website's prominent page, it's not affecting the functionality in any way. It's like S4, cosmetic defect, lowest severity. But the priority is like P1. Oh my god, we got to fix it right now. We can't let people, notice this mistake. That kind. An example of a low priority defect with low severity. So some simple spelling or grammatical mistake in an error message. So there's some error message on some page, and even if it's giving you the wrong error message, we can wait for, like a while to fix it. It's not impacting the functionality in any way. It's some problem with the error message, and it's only a spelling mistake on some remote error message. So it's low priority and low severity, right? Low priority defects with high severity. For example, the download quarterly statement button is not generating the statement correctly from the website at the beginning of the quarter. This is a high severity defect as it affects major functionality. So suppose there's a button called download quarterly statement. So people click on that statement and it gives you the statement for the entire quarter. Suppose that link is not working. That is a high severity defect, right? It's a major problem and there is no workaround. It's not crashing anything, but it's definitely S2 or maybe even S1. It's high severity. But do we have to fix it right now? Because when do people click on the download quarterly statement? Only once in a quarter. Suppose we are at the beginning of the quarter. That means people are not going to click on that link for the next couple of months. So we can actually wait for a couple of months before we can fix this. Meaning we don't have to drop everything and fix this issue right now. So this is a good example of a low priority defect with high severity. Our system crashes while using a legacy feature of ABC functionality when used with a non-recommended browser like IE7. Now IE7 is a legacy browser, so nobody really uses it anymore. So some customer is using IE7 and he finds the system crashes using some remote legacy feature. So it's a crash, so it's high priority. high severity, sorry. Any crash is like high severity. But he's using a non-recommended browser and he's using some legacy system, something like that. So it is low priority. So we're not, how many users are going to use IE 7? Most people are using IE 10 and 11, right? So that's a low priority defect with a high severity. So I hope you understand the difference between priority and severity. If you're going to be a QA manager or a QA lead or a scrum master or a project manager or even a product owner, you must be able to know the difference between a priority and a severity, and you must know how to prioritize defects for fixing. So what is a bug triage? A bug triage is a meeting that's held sometimes on a daily basis, sometimes twice a week, sometimes 3 times a week, sometimes once a week. So the frequency is determined by each project's complexity and situation. So it's usually typically a 1-hour formal session held every day or every other day in most large-scale projects. The participants must include the product owners, the technical architects, scrum masters, business analysts, QA team, and the development team. So all these people, or at least the QA leads and the dev leads, they're all in the bug triage. So every day, or every time there's a bug triage, they go over all the bugs that have been submitted, and they try and see what the root cause of these bugs are. So the product owners, the business analysts, and the technical architects provide inputs to the dev and QA team about how to fix the defect and retest it by performing a detailed root cause analysis. So they try to see what is really causing the bug. The tester and the developer might think it's really a very simple code issue, but the technical architect might step in during the debug triage and say, oh, you don't know, this is really a huge architectural flaw that we've unearthed, and he might give some inputs. But sometimes the product owners may say, this means the whole functionality was mapped incorrectly. This is really more complex than you think it is. So there's people from all aspects of the project, and they try to perform a root cause analysis of the defect and discuss how best to fix it by doing a detailed root cause analysis. So the daily bug triage format. The Scrum Master and the QA managers facilitate the bug triage session, and they try and introduce a sense of urgency. The person who logs the defects can put in their best guess for severity at the time of logging the defect. Product owners and QA manager collaboratively determine the priority of each defect during the bug triage. So if you let the product owners determine the priority, what would happen? Each product owner might be managing a particular module, and they would always want their module to have P1, everything should be done right now. So we can't let that happen. So we have to have the product owners and the QA manager work in collaboration to determine which bugs are really high priority and which are medium priority and which are low priority. And then if there's an offshore team or an implementation team somewhere, the developer leads. They determine which developer is the best person to fix each defect. It's usually the one who coded it in the first place. Or they can also give it to any other developer, whoever is most suited for this. And it's usually the person who worked on the corresponding user story. And they determine which developer is best suited to fix this defect, and they give it to him to fix. They explain to him, give inputs, and tell him how to fix the defects. Usually a lot of junior developers and resources are deployed for bug fixing. And now let's take a look at overview of Web 3.0 guidelines for UI-related testing. So Web 3.0 is like one of the latest standards in guidelines to design web applications for easy user interaction on all web-based browsers, smartphones, tablets, and other mobile devices. So if you're designing a website, you must take care not to shock or surprise the users. For example, a login is usually on the top right corner somewhere. And if in your website you introduce login button on like the bottom left corner, people are going to be looking all over your web page searching for the login button. That's not a good user experience. That would confuse them and make them angry. So that's a simple example, for instance. And Web 2.0 guidelines was only for web-based interactions, but Web 3.0 is for all mobile devices and media. So all web pages should have some degree of commonality in UI. Do not provide unpleasant surprises. For example, common icons must be in the places where they're usually expected to be. Use at least a 12 size font for all custom developed web pages for easy reading on all devices. So don't make the font too big or too small. Use at least a 12 size font. Use a common font, preferably one like Arial that does not have feet. Like this font that I've used on this slide is Arial. You know, if you notice the N over here, it doesn't have feet under it. And any font that has feet under it, like Times New Roman, it's more difficult to read. So use a font that doesn't have feet on all custom developed web pages for easy reading. Error messages are usually in red color. There was one time in some software project that I worked on where error messages were being displayed in green, confusing the hell out of all the customers. It was a bug, of course, and we fixed it, but error messages are always in red, okay? Warning messages must be in pink or orange. If a warning message appears in red, the user is like, oh my god, what did I do wrong? But it's only a warning message, so it's usually got to be in pink or orange. And a significant proportion of the population is colorblind. Do not let the users rely on color code to identify UI elements. A lot of people in the world are colorblind. You'll be surprised to know the statistics, look it up. And so use different icons for different functionalities. Don't expect users to be able to differentiate colors. So use different icons, different pictures, different, symbols to distinguish between different functionalities. So these are some of the guidelines, and this is all about defect management. And if you review this this video again and again, a couple of times, you must be well equipped to be a manual tester who can log defects in any software project anywhere in the world. Any company, wherever you go, these are the standard defect management practices. We talked about how to log defects, how it goes through the defect management life cycle, how bug triages are conducted, and the different types of defects and things like that. So if you are looking for a career in quality assurance or in any project, even in your university, if you have to do testing and defect management, I hope these guidelines will serve you. Thank you.